suppose I'll do a bit of an intro. So just like to welcome everybody tonight and to this joint event with the Cork Java User Group, and thanks again to the Cork Java User Group organisers as well for getting involved and helping us out. And so I guess it's a great pleasure to introduce Garth. You've probably met him at this stage. So we'll just get started. Okay, thanks.
Brilliant. Thank you very much. Cool. So, hi everybody. Just to say, all the material I'm going to be showing is available at this repository here, and that's the Wi-Fi details. Don't try and grab it now. I think what we'll do is I'll do the talk, and I'll introduce all the sample projects I have for you, and the structure of the code. So I'll run through the talk. And then we'll have a Q&A session, and then after that we can break up and do some hacking, so you can take my projects and have a look and do some of the quizzes I've got for you and try and extend them and so on, and then at 8:30 everything stops for pizza, okay? So it sounds like a plan, if that's okay with you? Yeah, cool, good, very good, yes. So it's hard in Ireland getting people to agree to things because you're all very non-committal, aren't you? See what I mean? Yeah. So, thank you very much. It's a great pleasure to be here, and I know that we've got two tribes in the room. So, can I just ask who are the functional cats? Yay! Very good. Excellent. Good. Yeah. And who are the Java users? Who here is of the enterprise? Yes, very good, welcome. So it's all been a hard day utilising synergy, and building up shareholder value. Yeah. Absolutely. Cool, good. So thank you very much for the invite. Just a little bit about myself. I was a full-time software developer for about 5 or 6 years, doing C++ and Java, mainly because .NET hadn't been invented yet. And then the opportunity came up to do some training, to run a few training courses. And I thought, what the hell, give it a go. Probably only last about 6 months, okay? That was over 15 years ago, which is terribly terrifying, okay? It's just, it's gone past like that. So I've done over about 1,000 deliveries. So I started out teaching people C++, then teaching C++ developers Java, then Java developers C#, and these days I teach everybody everything, because as an industry we can't make up our minds, So I'm head of learning at a company called Instil. Instil, we're up in Belfast, and we're your standard development and professional services companies, so half the company does software development. It used to be mainly web apps. These days it's mainly mobile. Lots of interesting stuff going on there. We also have the professional services side of the business, which I run, which is coaching, mentoring, all that kind of stuff. Like ThoughtWorks, only better. So also married with 2 kids. At the weekends, I have a second career as a Krav Maga instructor. So I do know how to kill somebody twice my size in under 3 seconds without making any noise. But that's not a skill I intend to employ this evening. Okay, so all being well. And my favourite thing in the world is Scala. Or rather, my favourite thing in the world is XSLT, but I don't admit to that in public anymore. So I used to be a huge XSLT fan. But these days I'm a big Scala fanboy. Okay, so that's my favourite thing in the world. Okay, so just to reveal my biases. First time I've been down in Cork for about 10 years, so I was trying to find a topic that we could all agree on, so I thought arguing about languages, okay, because everybody loves to argue about languages, and the closer they are together, the more fervent the argument is, okay, so, the Java and C# developers, they really hate one another, so just to ask, is anybody here of Mordor? Do we have any .NET developers amongst us?
I've started doing .NET.
Oh, okay. Don't worry. You're very welcome regardless. Burn them! Sorry, you're very welcome regardless. We'll start the conversion process as we go. Okay. So if you're familiar, I don't know if you can see the text of the cartoon. It's there can be no peace until they renounce their rabbit god and accept our duck god. So sometimes when you're arguing about languages, it does feel a lot like that. Especially when it comes to Java and C# and so on. So, as I say, we can run this a bunch of ways, okay? So, I'm just looking to see who has laptops and who doesn't, so probably best thing to do, as I say, is I'll do the talk, we'll do the QA, and then we'll get on to the hacking. Okay? So here's a little summary. I did a while back to try and explain where all the different languages are going. So as you know, we started off in procedural land, and the problem with procedural languages is once they get to a certain level of complexity, you reach the big ball of mud, where everything's wired into everything else. Okay, so I used to work for a company that did an awful lot of C programming, and they were maintaining C code that was 20 years old, and there were developers far smarter than me, but a busy week for them was looking at the code for 2 days in a kind of Zen trance, and then very carefully changing 3 or 4 lines, and spending the rest of the week testing it to see if it had worked or not. Okay, so nothing wrong with C. The first C compiler had to fit into 750k or something. It's ridiculous. These days, if you put Hello World into Word, that takes up 7.5 gig or something. I forget the exact value, but so not to run down procedural programming and so on. But once it gets to a certain level of complexity, you're talking big ball of mud, big ball of string, unless you're ridiculously careful in your coding conventions. So we moved into OO, and that's where I came in. I started programming in C++. Any C++ developers in the room? Yay, cool, be proud, yes. So as you know, C++ is a wonderful thing to have in your CV, the industrial equivalent of 2 tours in Vietnam, so you can turn around to all the Java developers and go, you weren't there, man, you weren't there, you're there in your virtual machine, I was out there in the world, So C++, really hardcore programming, the problem is, well, let me ask you C++ guys, let's say you had a graduate from college who only knew Java and you trained them up in C++. How long would it take before you really trusted them, before you would just let them loose in your code base and trust them to do whatever they wanted? So anybody care to give me a figure? 6 months, yeah, very good. I would say 12. So obviously you're a good teacher. So it takes a long time, before a C++ developer is properly matured. I always say that good C++ developers are like fine wine or cheese. It takes them a long, long time to mature. So because of that, we said, okay, let's move into virtual machines, and that's where we are today. Okay, but there's this big thing, and you've all heard the rant, you've all heard the story before. We're moving into a multi-core world, therefore functional programming is important, therefore every major language has adopted functional programming to some degree. So Java got it in Java 8, should have got it in Java 7, but never mind. C# got it back in 2008 with Link. C++ has had functional programming added in 2011 and 2013, but nobody I know actually understands it, but never mind. And so the existing languages, they've all had the functional programming stuff bolted on, but then you've also got a new generation of programming languages, that have the functional programming stuff in there right from the beginning, and that's your Scala, your Clojure, your Kotlin, and so on. Okay, so in the case of Microsoft, they came out with F#, and turned around to their developer community and said, look, this is brilliant, move over to it, and they expected it to work because I love this phrase, Microsoft create their own gravity. Okay, so they thought they could turn to their developer community and say, right, adopt F#. But one of the few times the .NET developer community just looked at it and went, no, too weird, we ain't doing it. Okay, so if you watch what people are doing with C#, what Microsoft is doing with the C# language, they're slowly turning it into F#. It's like, okay, you won't take the big vaccine, you won't take the big injection. Here's a dozen pink sugar cubes, eat the sugar cubes, okay? So in every release, C# becomes more functional, it becomes more like F#, okay? So whenever it comes to programming language design, it's a question of how much power do you want to give the developer and how much safety do you want to counterbalance that with. So in C++ you had an awful lot of power, but you also had an awful lot of danger. Okay, in Java you have slightly less power, but a hell of a lot more safety. Okay, but now that we're mixing in functional programming, well, we're increasing the number of ways in which you can shoot yourself in the foot. Okay. okay? Or, in the case of Scala, if you're not careful and you go full throttle for Scala Z or something like that, blow off both of your legs, okay? So, it's like whenever you go to the gym, are you going to go for one of these really rustic power lifting workouts, or are you going to use slightly safe apparatus or really safe apparatus? What's the balance that you want to get between having power features and having safety? Okay. So Java's always had procedural, object-oriented, and support for generics. Well, since Java 5, support for generics. But now we're mixing in functional programming as well. Okay, that's the new thing that came in Java 8, as you know. So let me just quickly ask, how many of you are actually using Java 8 at work? Yay, that's a goodly number. Excellent, good. So I'm anticipating some complicated questions then. Yeah. And how many of you are using Scala? I may be displaying slight bias there. We do. A couple of Scala people. Very good. Excellent, good. So what do we get in Java 8? Well, if you're using Java 8, which most of you are, you're familiar with this kind of code here. So let's say we've got a method called doThing, which takes a callable object, an implementation of the callable interface, and therefore has a call method, and it takes a consumer object, okay? So it takes an implementation of the consumer interface, and therefore has an accept method, okay? So prior to Java 8, if we wanted to call this method and pass in 2 simple jobs of work, we only want to do stuff that will be a line or 2 of code, okay? Well, what we need to do is we need to use anonymous inner classes, okay? So who likes anonymous inner classes? Thank you for making my point. Yeah, yeah. So that's why I always felt slightly bad, because I'm a big Java fan, but C# developers look at this and go, and JavaScript people do the same thing and so on. Yeah. So as of Java 8, we have lambdas, which everybody loves and massively overuses, because as you know, more fundamental than lambdas is method references. So one of the classic errors that everybody makes, is to use a lambda where a method reference will do, and you have to kind of train yourself not to make everything a lambda. Okay, so we don't want to do this anymore. This is okay, but we'd much rather use method references where appropriate rather than lambdas. And that's an example of the power that we now have in Java 8. Okay, so just a little bit of a pet peeve. They could have done this back in '96. Okay, it took me a couple of hours to find this quote. I knew it was there. This is back from the days of J++. J++ was the actual first Java IDE I ever used. Okay, so talk about having chocolate in their peanut butter. Anybody ever use Visual J++? Remember J++? No, cool. Oh yes, good. Yeah. So this was from the glorious few months, when it looked like Microsoft was going to fully embrace Java, and there would be one programming language to rule them all, So Microsoft had licensed Java from Sun, and we had the J++ IDE within Visual Studio. Okay, but then Microsoft went out and extended the technology to embrace it. And by embrace that might mean destroy, but that's a very old argument, and we don't talk about that anymore, and everybody's good friends. So let's not get into that. But they added delegates. And delegates went on to become anonymous delegates, which went on to become lambdas, which went on to become support for full functional programming. Okay, and the Java team back at Sun, they looked at this and said, no, we're not going to do that, because inner classes are just as good. Okay, so but in fairness, they wanted Java just to be an object-oriented language. They said they wanted Java to be a straightforward, minimalist, imperative, object-oriented language. And they didn't want to just throw stuff in for the hell of it. Okay, but they could have gone down that route back in the 90s. Yeah. Of course, it doesn't matter whether you're doing C# or Java or Scala, certain rules still apply, okay? So, I don't know your political views. I personally support the death penalty, for people who use multi-line lambdas, okay? So, not good, okay? So, in my personal view, lambdas should always be one line long, And of course, there are principles that apply across all functional programming languages. Okay, so these are some I particularly like. Yeah, especially this one from Michael Feathers. So OO and FP kind of converge on the same goal. Okay, and that's to enable you to write code which is understandable. Okay, so OO makes code understandable by encapsulating things. By taking all of the state and all of the complex logic and pushing it down. Into the details of objects. Yeah. Whereas in FP, we're trying to make code understandable by minimalizing the moving parts, by minimalizing the mutability, okay? And often we end up in the same place, just going by two very different routes, okay? So I'm sure everybody here has written a JUnit test or an NUnit test or whatever. Who's used Jasmine, the unit testing tool for JavaScript? Yay, cool. Whenever you write Jasmine, does it end up looking like JUnit? Because you've got function declarations within function declarations, yeah, and then you've got enclosed local variables for holding state, So if you were kind of bang your head off the keyboard and your vision went a bit fuzzy and you looked at it, it would actually look like a unit test, So the enclosing function could be a class, the nested functions seem to be methods using the state of the enclosed variables and so on, So sometimes we take very different routes, yeah, but we converge on the same solution. Okay, so any Haskell people amongst us? Oh, very good, yes. Yeah. So if you really want to get into functional programming, you could go out and learn Haskell. I've tried 3 times and given up each time, okay? Mainly because I don't have a really good motivation, we will eventually get there, But, yeah, so I just like that joke about Haskell, that everybody's trying to do it, okay? But it's kind of a cliche, to say, oh, well, you should learn that through Haskell, the way in all the American cop shows, the primary character is always an ex-SEAL, it just happens so much these days, it's a terrifying cliche, So, same thing with Haskell. Yay. So the question that I'd like to ask you guys, and I'm genuinely interested in what you think, is the question which is probably the big question in the Java virtual machine at the minute, which is, what is Java 8 going to do? Where is Java 8 going to take us? Okay, so will it be a gateway drug, or will it be the end of line? Okay, so I knew this wasn't going to be published, so I didn't want to put any drugs, on this particular slide. But the closest thing I have to an addiction is to fruit pastilles. I get really bad migraines, yeah, and when I do, only fruit pastilles will help. Okay, so especially a catering size pack. So there was one weekend that a really bad migraine. I was in bed, the covers over my head, and my wife came in with the fruit pastilles and just rattled them beside me. So my hand kind of came out of the duvet and grabbed them and pulled them in, So my wife was asking me if she could do anything for me, and all she could hear underneath the covers was So the only thing she said that would have made it funnier is after about 30 seconds if the empty wrapper had just gone poof and shot out from the duvet. So yeah, if I'm addicted to anything, I'm addicted to fruit pastilles. Yeah. So will Java 8 prove to be the gateway drug? Okay. In other words, will we look at Java 8 and say, "Oh, this is good"? Now I see what the point to all this functional programming is. Yeah. But isn't it a shame that we can't do it in a more functional style in Java? So will Java 8 gently push us, to using some of the more functional alternatives? That's what we mean by the gateway drug option. Okay? Or will we look at Java 8 and say, yep, good, now we've got lambdas, now we can make some of these parallel programming hacks that everybody talks about work, so good old Java, we can check that checkbox and that's it, end of line, okay? So that prototype that we had in Kotlin or in Scala or in Clojure or in Salon, maybe, that prototype, forget about it, okay? We're going to cancel it and we're just going to stick with Java, okay? And I genuinely don't know the answer to that question, okay? If I did, it would make my life an awful lot easier, So at the minute, in my team, we're trying to track all of these things, So we have a hardcore Kotlin fan, we have a hardcore Clojure fan, and so on, yeah. And it would be really good to know what the future holds, but at the moment it's very indeterminate. So what this talk isn't about is bashing Java 8, okay, because I love Java to bits, okay. So Java literally puts shoes on my kids' feet, okay. And whenever they added functional programming to Java, they did a tremendous job, and they deserve all the awards that they got, you know. So it's a classic glass half empty, glass half full situation, you know. On the one hand, they did a hell of a job, you know, getting all the functional stuff that they did into Java 8, you know, that's the glass half full. But the glass is also half empty, which is that they had to make an awful lot of compromises along the way. Okay, so just to set the scene, let's get judgmental, you know, and let's talk about the compromises. Okay, name the movie. Anybody? Anybody?
Equalizer.
Equalizer, yes, very good. Yes, Denzel Washington in amazing form. Yeah, the best walking away slowly from an explosion scene you will ever see. They really went to town on that, you know. But yeah, absolutely brilliant movie. I love that to bits. So here's my personal top 10 Java 8 annoyances. Okay, so these are the things that grind my gears, you know, whenever I'm doing Java 8, as opposed to Scala or JavaScript or TypeScript. Yeah. By the way, any of you guys use TypeScript? Yeah, we're huge TypeScript fans in the office, you know, so any time we're using JavaScript, we'd much rather make it TypeScript, okay? If you cut me in half, you know, you would find strongly typed written in the middle, you know, like a stick of portrush rock, you know, so it's, you know, I do like TypeScript a lot. So in approximate order, these are the things that grind my gears, okay? And very, very interested to see if you agree or disagree. So number one, functional interfaces. Okay, you know, so if I have to declare a reference to a lambda or a method reference, I want to be able to say val x equals, you know, or I want to have one of the nice syntaxes that you have in C# or F# and so on. Okay, so in those languages, it's really easy to declare a reference to a lambda or a reference to a method reference. Yeah, and if you have to give it a type, like if it's a parameter, well, there's a neat, nice little syntax for doing it. Okay, so the big majority of you guys have used Java 8, so then you've gone through the thing where, you know, not only do you have to use them as interfaces, you know, the references have to be of an interface type, but you have to go out and learn all of these common interfaces. Okay, and but because we don't want the overhead of boxing, yeah, we have to use the specialist ones as well. Okay, so let's say you want to have a reference to a lambda that takes an int and returns a double. Well, you could say function double integer, you know, and that would work. Okay, but then that would introduce boxing, you know. So what we should do is we should use the functional interface into double function instead. Okay, so that's my number one grievance. Okay. Grievance number two, yeah, the fact that you have to say .stream. Okay, so as you know, in other languages, you can do your filter and your map and your flat map and your reduce and so on, and you can do them directly on the collection type. You know, whenever they did Java 8, they didn't want to pollute interfaces. They didn't want to add a ton of extra methods to the list type and the map type and the set type and so on. So they said, tell you what we'll do. We'll say .stream, you know, and you'll get back a stream object, and then on the stream object, you know, you can do all of the standard methods, you know, which I like to call the functional toolkit. You know, whenever I'm teaching FP, that's just my personal term for them. Okay, so it's a bloody annoyance, you know, just having to say .stream all the time. Okay, the way that they got around it in C#, of course, was with extension methods, yeah, which was a nice trick, you know, but again, that they'd only so much room to maneuver in Java 8, so that they went down the road of saying .stream. Okay, by the way, as a professional educator, yeah, why did they have to pick stream? Yeah, because if I say stream, you all think? So, yes, I.O., yes, you all think networking. You know, so streams are really well established as being to do with I.O. Okay, so you know, if you were going to overload a word, don't use that word. I know why they did it, you know, because that's the standard accepted term in functional programming and so on. You know, but as a professional educator, I would much rather they go on with sequence. You know, and we had like a .seq method or something like that. You know, but they went the way that they went. Yeah. Number three, yeah. as you know, there are separate streams for primitives, okay? So again, for performance, to avoid boxing and so on, there's the generic stream interface, but you also have in-stream, double-stream, long-stream, and so on, okay? And then you have the methods that produce these, okay? So let's say I'm going to do a flat map. Well, there is the normal flat map function, yeah, but if the result of the mapping is going to be a double or an integer or a long or something like that, you know, then I'm supposed to use one of the specialist methods, okay? And certain methods like sum, you know, only exist in an int stream or a double stream or a long stream, okay? So I can't go to a generic stream and say dot sum, you know, it's got to be an int stream or a double stream or whatever, okay? So, yeah. And then, personally, number 4, let me ask you guys, does anybody miss having nested functions? You know, anybody who goes from like JavaScript or Scala to Java or C#, do you miss nested functions? Yes? Yeah, cool, good, yes. The problem is that if we're doing all our functional programming, well, we end up writing lambdas, yeah, but then we discover we need more than one line of code in the lambda, yeah, so therefore we don't want to do that because hard to debug, looks visually terrible and so on, so we write a helper function, okay? But then the trouble is the helper function pollutes the namespace of the class, okay? Because if I'm writing function A and I want to lift out a separate function B, but B is only required within A, you know, well then I want to be able to nest B inside A, okay? Now, I do remember the first time I saw this, whenever I'd only done Java before, and then at roughly the same time I started taking JavaScript really seriously, you know, and also fiddling around with Scala as well. And the first time I saw nested functions, it completely threw me for a loop. It made no sense, yeah? But then once you get used to the things, you never want to live without them, okay? So of course, anybody who does any JavaScript, you do this all the time. So for example, let's say here, I've got a little RESTful API, yeah? So I'm using RESTful.js. So I want to send a request to the server and fetch all of the courses. So I've got a RESTful service that will give me JSON describing training courses, you know. So I want to get all of them, and then, well, so that the get all will return a promise, yeah. So should the promise succeed, I want to call list all courses, you know. Otherwise, I want to call handle error, okay. So there's a bunch of code I want to put in there. So I don't want to use anonymous functions or lambdas or whatever. So I can encapsulate that really nicely as nested functions, okay. So once you get used to doing that, it's really hard to move to a language that doesn't have them. Yeah. Grant. So number 5, halfway there. Streams are single use, okay? So for those of you doing Java 8, I'm sure you've encountered this already. You can only use a stream once, okay? So you create the stream, and then on the stream you have a sequence of operations, you know, and one of these operations is the terminal operation, like for each, you know, it's the one that comes at the end, okay? So once you reach the terminal operation, that's it. You know, you can't use the stream again, yeah? And there's a very good reason for that. Oh, t-shirt question. Sorry, here's some t-shirts to give away. So this requires intelligence. So here's your first t-shirt question. Why is this the case? Okay. So in Java 8, why are streams single use?
Memory.
Sort of. Yes.
Lazy.
Yes. Very good. But you're an organizer, aren't you? Organizers don't get t-shirts. Yeah. Very good. Yeah. So t-shirt yours. I'll just throw these out by the way. Sorry?
I'm an organizer too.
Oh yes, okay. I was unaware of the fact at the time the t-shirt was dispatched, so therefore, Senator, you know, you still get a t-shirt. Yeah. So yes, you're quite right, it's laziness. You know. So here's a famous little puzzle, you know, most Java 8 demos have this kind of thing. So let's say we build a stream of integers, yeah, and then we filter it, okay, and then we're going to do a peek, okay. So peek is a kind of way of inserting some debugging, okay. So while the values are being processed, we're going to peek at them, and you see here we're just going to print them out. So I'm using message 1, and we're going to be printing out number survived filter, okay. So we only want the even numbers, you know, so we should see that the even numbers survive the filter, yeah. And then we're going to map them just to multiply them by 2, okay. Okay, so if you ask people what this is going to produce, well, most people expect to see, okay, demo begins, will get printed out, and then input has been built, will get printed out, and then we'll see one message for each number that survives the filter, and then it will say results have been built, and then we'll print out the results, okay? But if you actually look at it, this is what you get here. Okay, so all the messages from the peak, they come after results have been built. Okay, and the reason for that is that the way Java 8 executes this sequence of operations is a bit like the way a database processes a SQL query. So anybody done any SQL Server? Yeah, do you know, like query plans and so on? Yeah, where what happens is you give SQL Server the query, but it looks at it and says, "I'm not going to do it that way." That's really inefficient. So it comes up with the query plan, which is how it's actually going to implement your SQL query. Okay, but that might have a completely different structure. As long as the functionality is the same. Okay, so what happens here is that, as you say, everything is processed lazily. Yeah, and behind the scenes, it's building up a description, okay, and a stream description, and this is their equivalent of a query plan, okay, because if your terminal operation is going to be like find first, or find any, or something like that, okay, well then it knows there's only going to be one thing popping out the bottom, okay, or if your terminal operation is some kind of test, like all match or any match or anything like that, it knows that none of the intermediate results are going to be needed, okay, because all that's going to be coming back is true or false, okay. So it processes the information in a lazy way, and as it looks at the chain of operations, it's setting a set of flags, So each operation, filter, map, whatever, can result in a flag being set or a flag being removed. Okay, and then it's only whenever you're actually executing the terminal operation that it starts doing the things that you've asked it to do. Okay, so that's good, in terms of them having the ability in the future to do all kinds of cool optimizations, but it does have this downside, which surprises everybody at the start, including myself, which is that these things can only be executed once. Okay, so you need to produce multiple streams. Grand. So moving on, annoyance number 6, confusing reductions. Okay, so here's something I tried to do really early on and completely blew my gasket. Okay, so I've got an array of strings here, and you can't quite see all of them, but it's supercalifragilisticexpialidocious. Okay, and you can't say it without starting to sing it. And what I want to do, just for the purposes of a demo, is to concatenate them all using a string builder. Okay, so I'm sure you've all seen reduce before. So the idea is that I'm going to pass in a string builder as my initial value. So the first time the lambda is called, SB will be the empty string builder, and S will be the first string from the list. Okay, so we'll append S into the string builder. And then every time after the first time, SB will be the result of the previous call, and S will be the next item from the list. Okay, so because append returns the string builder, SB is always going to be the string builder, and S is going to be the next string. Okay, so I like to teach reduce as being like Pac-Man; it eats its way down the list. Okay, so what we're going to do here is append all of the strings into the string builder. Okay, except we won't. Okay, so it'll give us this wonderfully friendly error here. Okay, so you could be forgiven for running from the hills when you see that. Fortunately, I've done C++. I've used the standard template library. Okay, so for you C++ guys, do you remember getting errors that were like 4 pages long? And you get to the stage where that no longer surprised you, and just go. So I'm kind of immunized to this by C++, but even so, it's a truly horrible error message. Okay. Anybody know, another t-shirt question, anybody know what's actually missing? Okay, so whenever you do reduce, in Java 8, if you're passing in an initial value which isn't of the same type as the thing in the list, anybody know what you need? There's a
Combiner
third
or
thing.
something.
Yes, well done. Yes, it's an organizer. I'm trying to get rid of the t-shirts. You know, so next time you need a combiner. Okay, yeah. So yeah, perfectly right. Yeah. So what we need is we need a combiner. Okay. So because Java doesn't have operator overloading, we can't overload like plus or plus equals or anything like that. So if we were to do this in a parallel way, you know, what we divide the list up into sublists, you know, and we get a result from each one, and then we need some way to combine the results together. Okay? So whenever they did Java 8, they were introducing all of this stream stuff to enable things to be done in parallel. That was the whole point. You know? So they said, okay, if you're doing a reduce, yeah, and the first item is of a different type than the things in the list, well then you have to pass in a third thing, and that's a combiner. You know, that's the thing that knows how to combine them together. Okay? So a lot of people, including I'm sad to say myself, often just hack this. You know, so in parentheses you just say A, comma B, arrow null. Okay? Which will of course blow up massively if you try to do it in parallel. Okay? But it's not used if you do it in sequence. Okay?
It's so annoying to do that though, isn't it?
Yes.
I've had that before as well. I've probably played something like that as well.
Yes, yeah, amen, brother, amen. No, I feel your pain, yeah. And, but as I say, this is annoying 6 because it only grabs you occasionally, yeah. And because there is a way around it, okay? So what we all need to learn how to do is to learn how to use collect, okay? So in everybody's Java 8 journey, you know, one of the things that you learn is that this method called collect is vastly important, okay? So collect is just like reduce, yeah, except that you pass in a collector object, you know, and the collector object manages the job of work, you know, whatever it happens to be, okay? So let's say I wanted to do a reduction and I just wanted to count the number of items, okay? Well then I can do collect with a counting collector, you know? Or let's say I want to do a reduction and I want to join them all together, you know? Well then I can do a collect with a joining collector object and so on, you know? So there's a class called collectors with static factory methods for building all the collector objects, you know? And they've thought long and hard, you know, about the different collectors that you're going to want, you know? So for example, let's say what we want to do is add up the lengths of all the integers, so all the strings. Yeah. Well, we could do that with a reduction, but then we get into the problem discussed. So what we can do is we can say collect, yeah, and then we can call summing int, which will return a collector object that extracts an integer from each of the values and then adds them all up, you know. But of course, the summing int collector, it doesn't know what integer value we want from the string, you know. So we have to supply a lambda or method reference that can take a string and return an integer. Does that make sense? You know, so in our own little, we're all going to make this Java 8 journey, if we haven't made it already. We need to learn about collect. You know, we're going to be using it a hell of a lot more than we would in other languages. Okay? So, you know, that's annoying 7. In fact, we have to learn the damn thing. Okay? Next thing, underpowered optional. Yeah. So, again, this will only bite you if you're used to optional in other programming languages, you know, where in some languages it's option and some languages it's maybe. So as you know, an optional or option or maybe, you know, is a set of size 0 or 1. Okay, so in our functional code, we should never return null. We should return an optional object. Okay, so an optional of string may or may not contain a string. Okay, and then you can say things like, okay, if the value is present, then do something, you know, and so on. Okay. The thing is, if you've used option in other languages, yeah, it's a first-class data structure, okay? So anything you can do with a list or a set or a map, you know, you can do with an option, okay? So you get used to, you know, if you want to execute something if the value is there, you just say option.forEach. You know, you don't have to worry about a separate if present method or anything like that. You know, so in other functional languages, option is a lot more powerful and is treated just as a normal data structure. Again, it was Java 8, they did the best they could, you know, with the available resources, yeah, and this is one annoyance that's actually partially fixed in Java 9. You know, in Java 9, they've added extra methods so that optional can be treated more like, you know, a standard data structure, yeah, but still at the minute, you know, it's a gear grinder, yeah. Annoyance 9, this would be 1, okay, yeah, but you would think I was very mean if I made this number 1, okay, but this really, really, really ground my gears as an educator whenever I started into this, because if you're teaching people the functional toolkit, well, one of the easiest things to do, is just to say, here's a string, So let's take a string, and we'll filter all the characters in the string. We'll map all the characters in the string. We'll reduce all the characters in the string. You can't do it in Java yet, not easily, okay? Because they didn't want to come up with a char string, okay? So there's a whole big discussion, I put in a link to the discussion. I have to admit, I'm a trainer, so my programming is weaker, than a lot of people. So I use this site called Stack Overflow, where you can post questions and people get, as professional developers, I'm sure none of you go anywhere near this, but I personally find it useful. So there's a great debate on Stack Overflow where they said, look, where they lay out all the options, and they said, look, they considered having stream character, and they considered having a char stream and so on, and in the end they decided not to do any of those. So what you do is you have methods like chars and code points and so on, and what they do is they return an int stream. Okay, so you can use a string as a stream, but what you're actually getting back is integers. Okay, so if what you want to do is you want to have a demo of functional programming, where you're using string as your input and doing filter and map and so on, it is unfortunately non-trivial. Okay, so you end up doing stuff like this. So you end up saying call code points, and that will give you an int stream, and then filter and use character as letter and all that kind of thing. So it gets pretty horrible. Okay, and as an educator, that grinds my gears. And you can do all of this in C#, and I end up doing it in C#. Whenever I'm writing production code in C#, I do this kind of thing, link with strings, and it works quite well. So gear grinder.
Can you convert it to a power array and then make a stream from that?
Yeah, but again, as you said, that there are ways around it, but it just gets annoying. And then finally, number 10, just a pernickety one, but some of the naming, so you've got all match and any match. Why? Okay, well, why not just all and any? Okay, you've got none match. Why not just none? Okay, and then you've got find first. Why? Okay, my first degree was in philosophy. Okay, I worry about semantics a lot. I worry about the meanings of words. Okay, because I spent 3 years doing nothing but having arguments, and I got a degree at the end. Okay, but it was very heavily impressed into me that the meaning of words matter. Okay, so if you call something find first, I expect the find to mean something. I expect there to be some kind of finder strategy, if you know what I mean. So, if you have a method called find, you expect that to be a method with some kind of intelligence. So the idea of finding a thing and the idea of just taking the first thing, that these clash, in my head. Okay, so I'd much rather they just called it first. In the same way, find any. So find implies a strategy, any doesn't. Okay, so it's a chocolate teapot of a name. The two things don't seem to make sense when you mash them together. Okay, just my view. Okay, and then some of the ones that aren't there. So for example, you don't have find. Okay, you filter and do a find first. Why? Okay, there isn't single. I find single very valuable. So, in .NET you can say single, and it returns the only item that's there, but gives you an error if there is more than one item in the list. Useful. Sum and group by you have to do through collect. Combinations, really useful. We'll see this later. In Scala you can say go to a list and say combinations 2, and that will give you a list of all the pairs. Or combinations 3, gives you a list of all the triples and so on. Okay. So anyway, those are my top 10 gear grinders. Do you agree? Do you disagree? Do you want to throw chairs at me? Is there anything else you would add to this list or place higher? There's a T-shirt in it for you. Thoughts?
Do you think some of that will be improved if they improve the typing parents?
Maybe.
Or with your plans to improve the typing clearance?
I do, as far as I know, sadly not. Not to the degree that you'd have it in other languages anyway. So I think they have done as much as they possibly can. And as I say, they did a marvelous job. It's just that we are where we are. You don't want to do a C++. Okay, I know an awful lot of hardcore C++ developers. And I bought myself, Scott Meyer's Modern C++ book. Which is really good and explains all the new features. Every hardcore C++ person I've shown that book to is just going, no. So what we're doing with programming languages at the minute is we're doing reverse Jenga. We're gluing so many bricks onto existing things that eventually it just goes wee. And I think we've seen the demise of C++ for that reason. So we have dozens of clients, up in the north of Ireland and the UK and so on. And whenever I started teaching, I was teaching maybe one C++ course for every Java course. Then it was 2 Java for 1 C++. I think last financial year was the first financial year where I taught no C++ whatsoever. It had gone down to 2 or 3 courses, and it's now just boom. It's just gone. So we don't want to see that happening to Java. So anyway, let's look at some real code. Okay, so here's my level 1, demo. So things are going to get more complicated as we go. But here's my level 1 demo. And as I say, whenever we start hacking, this is something that you might want to play with. Okay, so what I've got here is there's a little project called Scala Workshop March 2017, and then we have some shared code here. And you don't need to actually look at the types. All you need to know is what it is. Okay, so in fact, I'll just do this through the slides so that everybody can see it at the back. So just take that off full screen. But what I've got is in both Java 8 and Scala, we've got this situation here. Okay, so please come up, please come up, please come up. Thank you. So we're going to create 4 trainer objects first of all, and every trainer has a name, a daily rate, and a list of their skills. Okay, so we're going to have 4 trainers. Okay, again, this is the Scala version, but there's a Java 8 version as well. And then we're going to build and return a list of courses. Okay, so you see here, every course has an ID, a title, a level, beginner, intermediate, or advanced. The number of days that the course lasts, and a list of the instructors who can teach it. That makes sense, okay? So we've got 4 trainers, and then we're returning a list of courses. Every course is the same as an ID, a title, a type, a duration, and a list of the instructors, okay? So I've got that in both Scala and Java 8. And then there's a set of methods I invite you to write. Okay, so there's a starter file in both Java 8 and Scala, and it has implementations of these, but it's procedural implementations. They're all done with conditionals and loops and so on. Okay, and the challenge is to take whichever you like and rewrite it in the functional way. Okay, but what I'll do is I'll just walk you through the solutions so quickly that you won't remember any of them. Okay, but we can just compare and contrast. Okay, so the first thing I ask you to do is find the titles of all the courses. So there's Scala, there's Java 8. Okay, so the Scala one, very straightforward, just map and then for each thing extract the title. Okay, by the way, in Scala, underscore means the first item the first time it's used, and the second thing the second time it's used, and so on. Okay, so we could say C arrow C dot title, but we could just say underscore dot title. And then for each of those, print it out tab. There'll be a little helper method called print tab that just takes anything and then prints it with a tab at the start. So that's the Scala version, that's the Java 8 version. Pretty much of a muchness, so that we can call that a draw. We're perfectly happy with that. And then let's say we want to find all of the courses which don't at the moment have any trainers, okay? Because some of the courses have an empty list of trainers. So if we just go back here, the Unix threading with pthreads, that has no instructors, and so does the metaprogramming in Ruby, okay? So if we go here, we can filter, So for each course, we want to get the list of instructors and find those which are empty, and then map it to the title and then print it out, okay? So you can see there, Java 8, a little bit more verbose, but still, let's call that one a draw. We're happy with that. then it starts getting more fun, okay? So we want to find the names and rates of all trainers, okay? So we don't have a list of the trainers. For each course, we can say .instructors, and that will give us a list of trainers, okay? So if we were to do a map, then over all the courses, well then we get a list of instructors, but what we want is just one big list of instructors, okay? So that, as you know, is where flat map comes in, okay? So we'll do a flat map, and for each course we'll get the instructors, okay? So now you can see that the differences start coming in. This is get instructors, we've got the parentheses, and we have to say .stream, that's a bit annoying, and then we find the distinct items, so we'll remove the duplicates, and then what we want is for each trainer, we want a pair of their names and rates, okay? So Scala and C# and so on have built-in support for tuples, and that's really nice, okay? So in Scala, if you put in parentheses, in a context where they're not normally used, there's a function call or something like that. So if you have a pair of parentheses being used, and there's no other context for it, then Scala assumes that you want to create a tuple, okay? So here we'll have a two-tuple of name and rate, okay? So if I was to have an 11th grind my gear, it would probably be lack of support for tuples, So to make this work, I went out and wrote a little pair type, okay? So that's so now you can see. I think we give Scala the win in that one. The number of advanced courses. Okay, so in Scala we could just say courses.count. So we want to say count the number of things for which this test is true. Okay, so count the number of things for which the course type is advanced. No problem. Okay. For Java 8, and by the way, shout if you can think of a simpler way of doing this. I just did it the way that made sense to me in Java 8. I've only been using it for a while. So I say courses.collect, and then I'm using a summing int, okay? So that summing int will build a collector object that returns a number, but we have to tell the collector what the strategy is, okay? So we're saying, okay, the strategy is if the type of the course is advanced, then it's a 1, otherwise it's a 0, okay? So that will give us the right result.
Could you filter and count?
Yes, you could. Yes, so we could also do a filter and count. But to me, this is clearer once you know collect. And I say, but we all have to learn collect for Java.
Java has a sum function on.
But only on the int stream. So you'd have to get the int stream first.
Do you map that to an integer stream first and then do some?
Yes, that would be another way of doing it. Absolutely. So whenever we're hacking, we can have a go at that and see if you think that's clear. Yeah, very good. Then a fun one, the durations of, sorry, the slide's slightly wrong. I just compressed the description a little bit. So we want the total durations of beginner and non-beginner courses, okay? So let's say some HR person rings up our training company and they say, okay, how many days would it be if somebody attended all of your beginner courses, Or how many days would it be if somebody attended all of your courses for intermediate and advanced people, okay? So there are many different kinds of training courses. Occasionally we do attaboy courses, where it's just a group of developers who've done really well, okay, and they get a course as a reward, so that's an attaboy course, attaboy, okay. So let's say HR want to do some attaboy training. So they say, these people have done so well, they can go in all your beginners courses, or these people have done so well, all your non-beginner courses. Well, very nice method here, partition, okay? So you have this in JavaScript as well. If you use like the underscore or Lodash libraries and stuff like that, you have this, So what this does is it returns a tuple, where item 1 in the tuple is all those things for which the lambda return true, and item 2 in the tuple, underscore 2, that's all the things for which the lambda return false. Okay, so if you do a partition, you're always going to get a 2 tuple back, a tuple of length 2, a pair, and the first thing in a pair will be the list of all the items for which the test was true, and the second thing will be a list of all the items for which the test was false. Okay, so we get 2 separate lists, and then what we can do is we can just say sum, so it just converts them to numbers and adds them all up. That makes sense, okay? The Java 8 implementation is interesting. Okay, so Yeah, I came up with 3 different ways of doing this, okay? You guys may come up with a 4th, 5th, and 6th that are better. I'd love to see, okay? So the first thing that I thought up was this, okay? So let's just do 2 damn filters, okay? So we'll have 2 helper methods, and then we'll do the kind of thing that you were talking about, you know? So we'll filter to get all the beginner courses, yeah? And then for each course we'll call map to int, you know, by getting the duration, you know? And then we'll sum them all up, okay? So I could do that twice. Once for the beginner courses and once for the non-beginner courses, okay? Or if that grinds your gears, because we're doing 2 filters, you could do it with a reduction, okay? So what we could do is we could pass in a pair of 2 integers, 0 and 0, and we could pass in this method here, total durations. See, what it does is it takes a pair of 2 integers and a course, and then in the pair, the first thing in the pair is going to be the total days of beginners courses, and the second thing in the pair is going to be the total days of non-beginners courses, okay? So we get the duration of the current course, yeah? And if it's a beginner, well, we add the duration of the current course to total beginners, otherwise we'll add it to total non-beginners, okay? And return a new pair with the adjusted values, okay?
You got your A, B, no.
Oh yes, quite right. Yeah, glad you spotted that. Yeah. So again, I wanted to get this out the door, so it wouldn't compile without a combiner, you know. But so I did the bad thing. Okay, you know. Okay. But now I've made the obligatory sacrifice to the compiler, you know, and this will compile and give us the right answer. That makes sense. Yeah.
There is a collector to do partitions in Java 8 as well.
There is, sorry?
There's a collector to do that.
Is there a Java 8 partition? Oh, sure.
But collector then.
Oh, I think, oh.
So what is
So collect has a partition?
The map where the key is true or false, and then
Yes.
the values are linked with the...
Oh, yes. Oh, that's brilliant. Let's try that later. Yeah, cool. So thank you for that. Yeah, cool.
Deserve a t-shirt.
Sorry?
Deserve a t-shirt.
Oh, yeah.
Pay for that.
I love it when people do my job for me. Thank you so much. Yes, good. Excellent. Good. And then I did come up with another way of doing it, which was to use collect in a much more basic way, you know. So I just did a filter and then a collect with a summing int. But I didn't know about collecting with partition. That's really good. Yeah, I'll look that one up. Then almost at the end, let's say we're running a really big delivery and we need a pair of trainers. Okay, so we've got a course with 40 people on it and we need a pair of trainers who can deliver Java. Okay, so what we do here is we'll do a flat map to get all the instructors. We'll remove all the duplicates, okay? We'll filter, so we only have trainers whose skills contain Java, yeah? Then we'll just lift out their names. We're assuming that all trainers have different names, okay? And then we'll use combinations. So say combinations is really useful, you know? It'll give me all the pairs, okay? So now what we'll have is we'll have a list of pairs of trainers, yeah? Where, you know, all the trainers are qualified to teach Java, okay? And then we can print them out, okay? Can everybody understand that? Yeah, cool. So that's code which has obviously no errors. In other words, if all the methods do what they say, okay, then it should produce the result we want. Okay. Here's the Java 8 implementation I came up with. Okay, I'm not going to try and discuss it in front of you. I'll get it wrong. Okay, so I can sit down and walk people through it. Okay, but it is not obvious. Let's just leave it with that. Yeah. Then the next one, the cost of JEE web development. Okay, so I want to go out and find the course whose title is JEE web development. Okay, and that will give me an option. Okay, but option is just a data structure. You know, so I can map it just like a data structure, and then I can say get or else 0. You know, and that will give me an option of double. Yeah, and that will be the duration of that course. Okay. And then I can go to the instructors, yeah, and for each instructor who can teach the JEE web development, yeah, well then I can get their name and multiply their rate by the duration of the course, you know, and that will give me my result. Okay, so all nice, yeah. Java 8 solution isn't as bad. Is almost as good. Yeah. Except, as I say, you don't have find. You have to do filter and find first. Okay. Which grinds my gears. Yeah. And then you can't treat optional as a data structure. You have to say if present instead of find each. Okay. So the Java 8 one ain't bad. Okay. But I still like the Scala one better. And then the final one, let's say what we want to do is we want to group courses, by type, okay? So we want to have a table where the keys are the course types. So in my data, there's only 3. So we want to have a table with 3 rows, beginner, intermediate, and advanced. And we want the values to be lists of courses, okay? So you see here, we can just say courses group by course type, and then for each we can say process, which processes the data in the row, And note that process can be a nested method, okay? Java 8, again, longer, still not too bad, okay, but we have to use collect and a grouping collector, and then our print group method can't be nested, it has to be a private method at the same level, okay? So again, not bad, but still not quite as nice as we'd like it to be. Everybody okay with that? Yeah. So that's that gives you an idea of the degree of relative disparity, between the two. Okay. So very quickly, just to finish off, 2 other things you might want to mention. Okay. Anybody write RESTful services? Yeah. Anybody write RESTful services in Spring? Yeah. Cool. Have you looked at Spring 5? Yeah, a few people, yeah. So Spring 5, they've introduced a new RESTful version, a new reactive version of Spring MVC. Okay, so if you're familiar with reactive design, it's something I'm not really qualified to talk about, but it's the idea that nothing should block. We should allow everything to be asynchronous, so we should build into our design the potential for any job of work to be done as an external thread, as an external task, or whatever. Okay, so reactive design and reactive programming is something that's all the rage. So back in the office, we're big fans of RX Java. Okay, so just out of curiosity, who here has done any reactive programming? RX Java, reactive,
reactor stuff.
Oh, yeah, very good. Yes, cool. Yeah. So in Spring MVC, they're going to push this very hard in version 5. Okay. So in reactive programming, you have streams. Okay. So you have your functional toolkit, but you have streams of items which are being dynamically generated. Okay. So they have a flux, which is a sequence of items which is being generated on the fly that you can map and filter and flat map and so on. And then for the simple case, they have a mono. Okay, so a mono is like a dynamically generated stream of items coming towards you, but there's only one thing on it. Okay, so if you're familiar with marble diagrams, it's like a pipe, which only one marble is ever going to roll down. Okay, so the powers that be, they want us to slowly move to reactive design and reactive programming and so on, so that our RESTful services and our web apps can take advantage of these, huge number of cores that's coming towards us. And I've got a demo that we can look at if you're interested. Yeah. And yet, okay, we've seen this before. Yeah. So I've been doing this for a while now, only in a teaching context. Haven't used this in production yet, but some of the guys have, with Akka HTTP. So quick show of hands, anybody used Akka HTTP? Yeah, just a couple, okay. So as you know, there's Akka, which was originally used from Scala, but you can use it equally now from Java, and it gives you an actor-based model for doing really concurrent stuff. And Akka HTTP, is their layer on top of it for doing RESTful services and so on. So you create a build file. I'm doing this in Scala, so SBT is how you do the build file. And then we just have a class with a main method. And I've written a couple of helper methods, one to shut down the server and one to just print, waiting until you hit return. And then they give you a really nice DSL for describing your routes. So there's a built-in Scala DSL that you can use to describe paths and prefixes and so on. And then it includes a little library called Spray, which will do all your marshalling to JSON for you. Okay, and the point is that this is here today, perfectly usable, being used by lots of companies in production and so on, So we don't have to wait for Spring 5, we can do all this already in either Java or in Scala, using HTTP, but because it's highly functional, if you go down the Scala route, your code is slightly nicer, as discussed. Yeah. And then one final thing to consider, which is that there's other stuff that you can only do if your language is sufficiently functional, okay? And my favorite example of this is property-based testing, okay? Now, to my horror, as I was about to come down for this presentation, I discovered you recently had an event in property-based testing, okay? So, can I ask who was at that event?
Did we get a t-shirt if I say I was the speaker?
Yes, you did. I consider that as a t-shirt worthy answer. Yes. So there we go. Yep. So how many people attended? Yay, cool. Okay. So for those of you who didn't, very, very quickly, good old Donald Rumsfeld, you have the unknown unknowns, okay? So no matter how good your unit or your QA tests are, you're still going to have unknown unknowns, okay? The things that you didn't test because you just didn't think about them, okay? It didn't occur to you that these are the things that might go wrong, okay? So what we do in property-based testing is we declare properties, okay? So here's an example, So we're saying, here's a property for all integers, number 1 plus number 2 should equal to number 2 plus number 1, okay? So you declare properties and then you give them to the testing tool and it executes them for you, okay? Passing in random values, okay? So what might your property be? Well, let's say you're trying to replace old code with new code. Okay, so let's say you've got some kind of financial calculations engine, and you say, here's the new one, okay, and the old one, and here's some input data. So the result from the old solution should be the same as the result from the new solution. Or you could do a round trip. Okay, so if you're writing some code to encrypt or zip stuff or whatever, you can say, okay, if you zip it and unzip it, it should be the same as the original. If you encrypt it or decrypt it, it should be the same as the original, okay? Or let's say you have to come up with a proprietary implementation of some open source library, okay? Well, you can check your code against the open source library, even if you can't put the open source library into production, okay? Or let's say you have to find the efficient way of doing something that can be done through brute force, okay? So your property should be that, okay, my super snazzy fast solution produces the same result as the guaranteed to work brute force solution. You get the idea, So there's a wonderful book I'll put up in a second on property-based testing, and it guides you through how you can do this, okay? So Scala gives you a little tool called Scala Check, that will let you declare these properties and then run them. Okay, so a lot of you have seen this before, so I'm not going to go into it in any detail. I'll happily sit down and talk you through it. But if I can just show you here, if you're new to Scala, this is something you might like to have a look at. So the projects that I've given you are the one that we talked about for doing trainers and courses. There's an example of a RESTful service written with Spring MVC with Spring 5. There's the same thing written with Akka HTTP, which you might like to have a look at. And then there's the poker hands kata. Okay, has anybody ever heard of a little kata called poker hands? So, no, there's a really good kata to do, I try and use this in my training courses as much as possible. So you've got a text file, and in the text file you have hands of poker, okay? So 3 of H is 3 of hearts, 9C is 9 of clubs, and so on, okay? And the challenge is to write a program that can read in each line and print out what the corresponding poker hands is, okay? As poker hand is, as a side effect, you'll get better at poker as well. It'll help you learn the different hands, okay? So I have a working implementation for this. And in fact, in the office, we have this in C#, in Python, you name it, we have it, and because it's a great teaching tool. And for any language which is sufficiently functional, we have a pure functional solution. Okay, so there are many ways of doing it. You can do it in C, just playing around with chars, and we haven't performance tested it, but I would imagine that that gives you very good performance. But once you get this kata working in an imperative way, it's really good idea to have a go at doing it in a purely functional way as well. Okay, so one of the projects that I've given you, is a purely functional solution, to the poker hands kata in Scala. Okay, so if you want to get familiar with Scala, or if you just want to learn a little bit more about FP, this is a great kata to do for yourself, and then have a look at my solution and slag it off. Okay, so it has unit tests as well. So it has ordinary unit tests written in Scala test. So Scala test, really, really good testing tool. But it also has property-based tests, okay? Because this is an ideal thing to do property-based testing with, okay? We did do this in an induction program with a guy who had a PhD in maths, and he did write code, that generated every possible poker hand and tested it, okay? And we were awestruck, okay? But it took him a long time. I don't know how long it actually took him. He went away, and about a month after the program, he came back and showed us the code. I'm not saying it took him a month, but it was non-trivial in that wonderful phrase, okay? So what we can do with property-based testing is, first of all, we can come up with a generator that generates hands of poker, okay? So all you need to know is that this thing here, will generate a random hand of poker, okay? And we have to do certain checks. For example, we have to make sure that the hand doesn't contain the same card twice, okay? Otherwise, you shoot the dealer, okay? But this is a generator function, which will build a poker hand, And then what we can do is we can go out and check a property by passing in random poker hands. Okay, so I've got it set up here so that it's for each property that I write, it's going to run it against 50,000 random hands of poker. Okay, and then I can write some properties. Okay, so you see, here's my first property. Dead simple. All we're saying here is that within 50,000 hands of poker, there should be a pair. There should be a two pair. There should be three of a kind. There should be a straight and a flush and so on. Okay? So if we deal 50,000 hands of poker and there's no pair in it, okay, well then either I'm the most unlucky bugger on the planet, or there's a bug in my code. Okay? Probably there's a bug in my code. Okay? I've commented out the is royal flush one because whenever I run this as a demo, occasionally there isn't a royal flush in 50,000 hands of poker. It's just not enough. Okay, so sometimes that goes wrong. But then once we've tested that, we can also test that if a hand is a two pair, then it should also be a pair. If a hand is a full house, well then it should also be a pair and a three of a kind and so on. Okay, because poker hands are nicely set up for poker for property-based testing because there are things that are true. There are multiple things that are true for each hand. So if it's four of a kind, then it must be three of a kind and two of a kind. If it's a full house, well then it is a pair and it is a three of a kind as well. Okay, so that gives us a way of writing properties. Okay, so I've got a bunch of properties here, which all work, and every time I do the course, people come out and suggest new ideas, and I'm too lazy to put them into the demo. Okay, so but this is a very nice example. It's a very nice kata, A to implement, B to unit test, and then C for doing property-based testing. Okay, so at a future event, I really recommend it. It's a good one. It keeps everybody busy for at least 3 hours. So it's a good week after. And did you recommend this? You can do property-based testing in any language that's sufficiently functional. So there's the F# implementation, there's a Python-based implementation, and there's Scala check as well. So there's a very, very good book in Scala check. And most of the stuff in there applies to property-based testing in general. Not just with that tool. Okay. So those are the 3 sets of examples. That I wanted to give you. So. Now's the time to ask the question, what do you think? Okay, so what's your personal opinion? You know, in terms of gateway drug, yeah, or end of the line. Okay. So whenever you look at the functional stuff in Java 8, do you say, yeah, that'll let me do the parallel stuff, but here and no further? You know, I'm not interested in taking this any further. You know, or are you hungry for more? Okay. So do you look at this and you go, oh yeah, I see why this is useful. I want to use Scala. I want to use Clojure. I want to use Kotlin. I want to use F#. You know, what the hell? Let's go the whole hog and learn Haskell. Okay. So show of hands. Yeah. Who is happy with Java 8 as it is, and that's it and no more? Anybody? Okay, cool. Who's interested in taking it further? Good, yeah. Who just wants pizza? Interesting, yeah. So, as I say, nobody knows the future. Yeah, it will be interesting to see what happens next. Yeah, I do recommend having a look at Scala simply because Kotlin was very explicitly created as a scaled-down Scala. They just thought Scala was too complicated and too dangerous. You know, so they went for Kotlin. Swift, you know, you can find all these sites that compare Swift to Scala and say the same. You know, so at this stage, the next big thing probably won't be Scala. Maybe not. We'll have to see. Okay, but if there was going to be a huge Scala revolution, it would have happened by now anyway. What's probably going to happen is that you know, everything will stay. There will be a Clojure community. There will be a Kotlin community. There will be a Scala community. There will be a Java 8 community. My job will be a living hell. You know, but we'll still end up using a little bit of everything. Yeah, but the functional stuff is out there if you're interested. Okay, and if Java 8 gives you a taste, well, there's all kinds of goodness in Scala and Clojure that you might want to have a look at. Okay? So that pretty much finishes everything I wanted to say, yeah, except if you're going drinking after this, please do enjoy your party. Okay? Any questions? Yes?
There is a third alternative that might be that in a later Java version, some of your concerns are addressed. Is that a realistic opportunity?
Well, that is definitely worth debating. I would say I don't think they can take it much further. You know, so I think with any programming language, as you add more and more complexity on, you're eventually backing yourself into a corner where, you know, if you either you just can't do any more, or you break backwards compatibility. Okay, and ask the Python guys about breaking backwards compatibility. The number of Python courses we do that break my heart, because we've all this wonderful Python 3 material, you know, and the client rings up and says, "It must be Python 2." You know, we're using one library that only works with Python 2, and that's a deal breaker. You know, so there are very, very good reasons for not breaking backwards compatibility. So other people may know better. My personal instinct is I don't think they can design their way out, you know, of some of those problems that we were talking about. Yeah. Question? Or
just a comment, but the commitment to backwards compatibility is the source of so much complexity in.
Yeah.
They would have had the opportunity to refactor the collections library, for example. They could have, you know, when you query a map or something, the key isn't present, you could have returned an optional from Java 8 onwards, but they're not going to do that because that would break everything. The split type system as opposed to Scala where everything is...
yes, absolutely. But I mean, what I would say is never underestimate the importance of everything just working. You know, I remember in the days whenever I did C++ consultancy, and I'd be in with the client and I'd see them writing something, and I'd say, "Okay, dude, that's brilliant code, but you know there's this wonderful open source library that can do it." And they go, "Oh no, but that was written by somebody on a different platform, and it doesn't use make, it uses some variant, and we tried to compile it, and we've just given up." Okay, so one of the reasons why Java did so brilliantly was platform independence, not because users wanted a GUI that ran on Windows and Unix and so on, but that you could download any open source Java library, regardless of what version it had been written in, regardless of what platform it had been written on, and it would just work. You know, that's always been the secret source of Java, that you don't, the secret sauce, that you don't have to worry about that. It's all handled for you. So I think they're very wise to be very worried about doing anything that ever breaks that. You know, just as I say, that the example of Python is a really good one. Just the number of companies in industry who are unable to move off Python 2 because they're just slaved to some legacy library that they just can't get ported up, you know, for various reasons. Any other questions? Going once? Oh.
It's not a question, it's more of a comment, but in my opinion, one of the main selling points of Scala, for example, as opposed to compared to Java, would be the fact that you can define your own closed type hierarchy.
Yes.
And that gives you so much power.
Yes, yeah.
You get so many guarantees that you can't get in Java, really.
Yes, yeah.
So the fact that you can define your ADTs is just...
Oh yeah, absolutely. As you say, we're only talking about one level here, but once you've drunk the Kool-Aid, there are other levels above, that you can get into, and all that type-dependent programming and stuff and so on. And have you played with Idris?
I haven't. I knew of it, but...
Yeah, I've tried to, but it just blew my mind. I need to spend more quality time in Scala with the kind of stuff you're talking about, and then I'll be ready to look at it. But yeah, I think you're completely right that, if we get sufficiently functional, there's all this other stuff on top of that we can take advantage of. Yeah, absolutely. Any other thoughts? Cool. So what I'll do is I'll leave up that link, and there's a memory stuff with all the projects on them, and I'll help you get set up, okay? So by all means take those and have a play, or if you would just like to do some more Q&A, that's grand, or if you just want to feast on pizza and then slink out the back door, that's fine as well, okay? But I'm here for as long as you like, because only going back to the hotel to watch whatever Steven Seagal movie is on, okay? So, save me from Under Siege to the Dark Country or something. Just save me from that. Okay? So look, thank you very much indeed. Thank you for your attention. Cheers.